This is something I picked up on Amazon, but it's really just a product out of a Chinese seller. Here's the Amazon listing. It's called the 6 Coils Ring Accelerator Cyclotron High-Tech Physics Model for Teaching Desk Toy, $117. So a little bit steep, although I have a few bones to pick with the listing. The dimensions they give are not reliable. They make some claims about the product which are inaccurate, and they have some confusing photographs. You know, this is all well and good. It shows the product pretty accurately, but there's this listing, or this photo, which shows a 4-coil product and a 6-coil product. You can only pick the 6-coil product. It's not like they give you an option to buy one or the other. So they really shouldn't have had this confusing 4-coil photo in here. Apparently they make or made a 4-coil version at some point. Anyway, this product is a 6-coil product. Now it's really just a brushless DC motor with an unusual configuration. It is not a cyclotron by any stretch of the imagination. All you have to do is look it up and see what a cyclotron is, and this ain't one, not even close. It's not at all high-tech. It's just the most basic stuff, nothing more advanced really than a DC motor, except that because it's brushless, it has a little bit of electronics, but nothing at all high-tech. Very basic stuff. It's a ring accelerator in the sense that it's ring-shaped, and the electromagnets distributed around the ring impart a small acceleration to the steel ball that's rolling in the track to keep it moving, but it isn't what is usually called a ring accelerator, which is a more constant acceleration kind of thing. Again, it's really just like a DC motor, where you're energizing different coils at exactly the right time to keep something rotating. The goal is not to continuously accelerate it until it gets to ridiculous speeds. It'll reach a certain point where it's the speed the thing wants to be running at, and then it'll stay at that speed. Alright, they do say it's 20 or 30 by 30 by 8 centimeters. That may be the size of the box that it comes in, but it's misleading when they say that because the product isn't that big. I've measured mine, and it's about 9 3/4 inches diameter, or about 24 3/4 centimeters, so a significant departure from the 30 centimeters. And since it's round, they don't really need to say 30 by 30. And then the height or depth dimension is only about 5/8 of an inch, or about 6.7 centimeters. So again, substantially below the 8 centimeters they claim for the product. So let's take a closer look at this thing. It's laser cut acrylic. That's what the base is, and then there's something, it may be ABS or something, it may even be 3D printed. I'm not sure how they made this track. It's got kind of a textured surface, like maybe it's 3D printed. It's possible they might also have just gotten a piece of plastic tubing, cut it in half, and then heated it up and bent it around a mold to get it into this shape. And the track is really 2 pieces. There's a seam here and a seam here, so it's 2 halves glued together, and you would need to do that in order to fit them through the cores of all these electromagnets. Then there are the little acrylic braces that come up, and the track is glued to those, holding everything in place, and the heavy electromagnets are held down to the base with 2 zip ties each. So I put it on my postal scale, and it's about 36 ounces, not counting the power supply, which I haven't shown yet. And that comes to just about an even 1 kilogram of mass. So that gives you some idea. It has clear rubber feet on the bottom in quite a few locations, and so it sits pretty nicely on a tabletop. Before I get into the details of each magnet, I'm going to digress for a moment and show what else comes with this product. One thing is the power supply module. It's just a power brick, very generic. It's not designed especially for this product. You could use anything that provided similar power. This one is a universal switching power supply. Input AC power or mains power is anywhere from 100 to 240 volts. Anywhere 50 to 60 hertz is fine. The output is 12 volts regulated DC at up to 5 amps. And it terminates with a pretty conventional 6mm diameter barrel plug. Pretty much everything uses this size of barrel plug these days. So you could use some other power supply that had the same barrel plug and you wouldn't need this one. In fact, it's probably a pretty cheap power supply. It would probably be the greatest point of failure, the greatest likelihood of failure of this whole thing. If anything fails, it's probably going to be the power supply. So if that happens, you're not stranded. You could buy anything else that has a 12 volt regulated output of at least 5 amps. This particular one has a very short AC power cord on it. It's only about 16 inches long. That's including up to the tips of the prongs. So that's pretty short. It would be nice if it was longer. This one did come with a US style 2-prong power plug. I don't know if they sell ones with different styles of plugs depending on where the orders are going to. The power supply was in its own cardboard box that was packaged along with the box for the rest of it. So that would allow them to swap out power supplies depending on where the orders are going to. I can't say if that's what they're doing. I should also point out that it's center positive, the way it's wired to the barrel connector. So that's conventional as well. The DC power cord is about 3 feet long. So that's good. At least you've got that. But, you know, if you plug this into an outlet and then you have to run this, the DC side cord, you can't go all that far before you run out of cord and you wish it was a longer cord. So a small gripe there. But again, you're not locked into this power supply. You can buy any number of inexpensive switching power supplies that would do the same thing. Or if you're in a laboratory or something and just want to run this for the hell of it, you know, a lot of lab power supplies would provide that power. Let's get back to the structure of this. So we have 6 identical magnet modules. Basically a simple electromagnet. It's not even on a, you know, iron core or anything. It's just an air core electromagnet. And there's a little round circuit board stuck onto the side of each spool. They're all powered from the same power, and the circuit boards are identical, but only one of them has the 6mm barrel socket or jack on it, and that's just soldered to one of the boards, but all of the boards have a place to solder a power supply jack onto. Then there's dual copper bus rails or bus bars that start with that jack-equipped module, and then it feeds all the way around until it gets to the last one. It does not make a complete ring. Now let's take a look at one of the 6 magnet assemblies. So we've got a plastic core with a big heavy copper winding around it, and this is quite heavy. I didn't weigh it. I think I will. Looking at one of the modules, being a DC motor, there needs to be some way to commutate the applied power to whichever coil or winding needs to be energized at a particular time. So there needs to be some way to sense when it's appropriate to energize each coil. And in this case it's done optically. There's this little LED here, and it's an infrared LED. It does not produce visible light, so it'll appear like it's not working, but it's really flooding infrared light in that direction. And then this little black thing that looks like a little black jelly bean, that is an infrared phototransistor. So it senses the infrared light. And across the power supply coming into each one of these boards, the LED and the phototransistor each have a resistor, and those are little surface mount resistors you see around on the board. A couple of those are used, one for this and one for that, to make them function. And so basically when the ball is not in the track, or not in this position of the track, the infrared light shines across and turns on the phototransistor, and that changes a voltage on the circuit here. And then there is a very simple circuit comprised of another resistor or two, and right in the middle of the picture there's a little 3-terminal surface mount device. That's a little transistor. I'm presuming it's just a bipolar junction or BJT type transistor, just to act as a switch or buffer or current amplifier between the phototransistor and the power device. And then there's this power MOSFET, that's this big thing in the middle of the picture, and that's what actually switches the power to the magnet. And it has a resistor associated with it as well. So whenever the beam, the infrared beam, gets broken by a ball, and the ball would be rolling in this direction, so it hits the beam here, breaks the beam, that turns on this power MOSFET, so it takes the power on the bus rails here and applies it directly to the coil, energizing the coil, and then that creates a magnetic field that tries to draw the ball inside the magnet assembly. So the ball's sitting out here, it breaks the beam, the coil's activated, it draws the ball into it, which accelerates it in that direction in doing so. And once the ball's rolled inside this assembly, it no longer breaks the infrared beam, so that turns off the MOSFET again, so the coil's de-energized. So really it's just when the ball is moving in this direction and it first breaks the beam, you get a brief pulse of magnetic energy that draws the ball in and then shuts off right away again. So the ball has been accelerated slightly in that direction, and it keeps rolling, passes out of the magnet, coasts around to the next one, which is only a couple inches away, breaks that beam, energizes that magnet, gives it another little kick because it's constantly decelerating from friction as it rolls around, and then it gets re-accelerated just a little bit, then it coasts, decelerating, gets another kick, and so on all the way around. None of these modules knows there's another module in here. They don't communicate with each other or anything like that. Each one thinks it's the only one on the track, and indeed if you took all the other ones off, if you cut the bus power, for example, so only one of them worked, this would probably still function. The kick from one magnet would probably be enough to get the ball to slowly roll around and just barely make it back to the one and only magnet to get kicked again and roll around. But when you're able to keep kicking it, you know, at a fairly high rate of rapidity, if you will, then it doesn't have a chance to slow down much, and it'll reach a certain stasis where the time constant that you get from breaking the beam to the field being generated and then de-energized and broken the I'm phrasing this poorly, but the pulse of energy you get in here is only on for a certain amount of time, and that's set up by the physics of this thing, and it'll never go faster than that. It's not like it's just going to keep going faster and faster and faster. The physical constants of this thing will get it going up to a decent speed, but not a crazy speed, and not dangerous. you can stick your finger in here and the ball just bounces off your finger and stops. So safe for kids, I would think. Wouldn't hurt pets around it unless they chew on it or something. It's only 24 volts or 12 volts, so it's really not hazardous. And the power supply has short circuit and over temperature and things like that protections built into it, no doubt. So, you know, pretty safe as a toy, I think. It's not all that much fun to see it running, actually, because you can't see the ball once it gets going. You just hear the noise of it going around. So what they've done here is, in addition to what I've already described on each board, there are two little surface mount LEDs on here. One of them is just right off the power, so whenever power is applied, that LED is on each one of these modules. So in this particular version of the product, the power LED is amber or yellow. So you have 6 little amber dots of light on here, and that says it's on and it's working. And then during the time the infrared beam is broken and the magnet is energized, the other LED turns on, and that one on this particular version of the product is green, so you get a little pulsing flash of light. And so that'll propagate around. You'll have a green flash, a green flash, a green flash rippling around. And that's actually what you can see more readily than actually spotting the ball once it gets going. So let's take a look at the theory. I have not traced out the specific circuit on these electromagnetic modules because they're using the black circuit boards with the black matte silk screen, so the foils on the circuit board are all but invisible. It'd be very difficult to trace them, and because the way they're mounted on the track and everything, you can't hardly get a good look at them anyway. So I just counted the components and the types of components and reasoned out what probably is there. So what I think you probably got, this is the one bus bar that's got the positive supply, the positive side of the supply, that's 12 volts, and this is the other bus bar that has the minus side of that supply. So the first thing we have to do is have an LED that turns on when there's power applied. So there's that LED. This is power. It's going to have a current limiting resistor and the LED itself, and it'll just be right across the power, nothing more complicated than that. And then there's going to be a similar setup for the IR LED. IR. So it will light up, but of course invisibly since it's infrared. Then there's going to be another similar structure in the circuit. Another resistor. In this case it's acting as a pull-up instead of a current limiting device, although it does that too. So normally you've got infrared energy emitted by the IR LED, and that's going into the IR phototransistor. And as long as it's doing so, this transistor is on, and it's pulling this point here down to this voltage or close to it. Otherwise, if you break the beam, then this transistor turns off, and this resistor pulls this point up close to this voltage, up closer to 12 volts. And then I suspect what we've got is probably, well, just because of the number of resistors in the circuit, I'm guessing there's a base resistor. So this is probably a little BJT transistor in there. Well, I don't want to make assumptions here. This could be an NPN, it could be a PNP, it could be an FET, it could be any number of things, and I don't know how the resistors are used or in which configuration this device is used, but I'm just going to leave it at this, that And this could be upside down too. The transistor could be on the top and the resistor on the bottom, which would invert the signal coming out of it. I don't know those things. Let's just say we've got a pulse coming out of this photo transistor. It's getting buffered, amplified, cleaned up, or something by some sort of a transistor in this position. And then that produces a pulse to the gate of this MOSFET. That's the power switching device. And it's connected between the plus and minus sides of the power supply with a coil. That's the magnet coil. So whenever this is turned on, then the power of the power supply can go through the coil, through the transistor, and back to the power supply, and you get your magnetic field until such a time that the infrared bead is reestablished, and then this turns back off, the coil is de-energized. Because when you de-energize a coil, you get a high voltage kick developed across it, which could damage the components and so on, not to mention generating electromagnetic interference for radios or what have you. So there's a so-called freewheeling diode on the circuit board that's across the coil, so that the high voltage that's generated when this is de-energized is opposite the normal polarity. So this is the plus side when it's de-energized, and this provides, like putting a crowbar across it, it just shorts out that energy, so it never really develops a high voltage spike. It just clamps it right away. And then the power MOSFET itself has an internal high-speed diode that helps protect it as well. I don't really think there's anything more to the circuit than that. Somehow we have to account for the about 6 resistors in here. There's certainly these 3, another 1 or 2 associated with this transistor, etc. But also, I don't know for sure how they've wired in the additional LED, the one that flashes when it turns on. It's probably wired in around this transistor. It might be in series with one side or the other of it. You know, maybe the LED's down here somewhere. There's probably a resistor associated with it, something like that, whatever the configuration of this is. So I think that's enough explaining how this probably is working. The other things that come with this product, at least from the seller I bought mine from, is a pair of steel balls. I've checked them. They do not seem to be in any way magnetic. Don't seem to have any attraction at all with steel items, or each other for that matter. They're just ball bearings. They are a good size to fit in the track, a little bit undersized so they're not pinched in there. So you've got one. If you lose one, I imagine they would hurt worse than a Lego brick if you stepped on one, or at least as bad as a Lego brick. And you could replace these with any steel balls of approximately the same size. So even if you lose them, you're not dead in the water. So let's do a quick demo. Okay, I've plugged it in. I run the cord under the base. The little feet are high enough to give you there's just enough clearance for the cable to slide under there, and then the cable goes up and plugs in here. It'd be nice if it plugged in lower so it wasn't this ugly thing sticking up here. I think they could have put the jack down here so the cable could have just gone downwards. But again, we've got the amber LED on every one of these modules lit up. So let's put a ball in and watch what happens. And that's about as fast as it gets going. It's approximately 2 revolutions of the track every second. So not exactly a speed demon. And you just kind of get a blur of the ball going around. And you can see if it matches the camera frame rate, you get the green LED flashing. Here it looks kind of spastic because the timing of the flash is aliasing with the frame rate of my digital camera. But in reality, it's flashing at a constant rate. In my experience so far, I have not run this for more than about 15 minutes at a time, and nothing gets hot. The power MOSFETs aren't even warm, so I don't think they're being stressed. The Amazon brand of this product, and it comes out under a lot of other brands with slight variations. Some of them have only blue LEDs, which is just butt ugly in my view. Everything is blue LEDs these days. So at least this particular version of the product has more pleasing green and amber LEDs, and they're not so glaring and garish. Some of them do not come with this plug from the photos I've seen. Some of them just have wires tacked onto these bus bars and running out to a little plug on a short piece of wire. You may find that variation as well. So I think that's about all I can offer about this particular product.